In this video, we're going to explore the Unit 3 portfolio for PreCalculus A. Unit 3, PreCalculus A. It's called the Let's Dance portfolio. There is a worksheet, so you're going to have to go to the lesson at the end of the lesson, print out the worksheet. I'm not going to provide it here. It's copyrighted. We can't put it on our website. But I am going to talk about it, explain some of the concepts behind it, and so forth. It's called Follow the Dancing Robot, or the Let's Dance portfolio. And so it asks you to examine the graph of f of x equals x cubed. To examine that here, I'm going to use Desmos. So let's pull up Desmos here. Desmos.com/calculator. Okay, I'm going to put these screens side by side. All right, so let's examine the function y equals, or f of x equals, x cubed. Okay, one of the things you should notice right off the bat is that one arm points up, all right, so to speak, points up, the other arm points down. It being an odd function, it actually does that. And let's explore that just a little bit. If I change that to y equals x to the 5th, y equals x to the just x, y equals x to the 7th, y equals x to the 9th. What do you notice about all these numbers? Hopefully you notice x to the 9th. Hopefully you notice that they are all odd numbers, and that in fact is why this is called an odd function. You notice they all have this origin symmetry. That is, if you take the whole thing and flip it spin it 180 degrees, it matches itself. It simply gets steeper and tighter the higher the exponent. Okay. Just to explore this concept a little bit further, if I change that 3 to a 2 instead of a 3, now both arms point up, right? And this is known as an even function. Y equals x to the 4th, y equals x to the 6th. Okay, it's doing the same thing, but both arms are pointing up. X to the 8th, and so on. Okay, it just gets steeper and steeper and steeper. Okay, all the way out, in fact, I can do y equals x to the 1000, which is an even number. And then you notice it creates almost a square corner. That's an interesting thing to examine. It's not truly vertical, because anything that would be vertical would not actually be a function. But we're talking about x cubed, and you're asked to use the graph to animate the robot dancing. Okay, so our first question, our first task, is to make the robot jump up. Okay, and there's a number of ways we can do that. Actually, there's just one. If I add 4 to the outside, the whole thing jumps up. Okay, in fact, let's do this. Y equals x cubed plus 4, and you'll notice the black one is the same as the red one, just moved higher. If I change it to a minus 4, it moves down, right? And if I want to move it to the left, I'm going to put a parenthesis around the x, and I'm going to say minus, and they want us to move it left too. Well, that moves it to the right too. Okay? So, but if I change this to a plus 2, it moves it to the left. And it's kind of interesting that to add something moves it up, to subtract something moves it down, but to add something to x moves it left, and to subtract something from x moves it right. So in my mind, I think of it this way. Anything I do to x, to the independent variable, has the opposite effect you might anticipate. Okay? It moves it to the opposite direction. Okay, and we're talking about flipping his arms. So let's play with that here. So we're going to start with x cubed. How do we flip his arms? Well, we put a negative in front. Now the left side is up and the right side is down. Okay, so that's fairly straightforward. Putting a negative sign in front flips it. Now spreading his arms twice as wide, that's actually a tricky thing to do. If I put a 2 in front, that doesn't raise his arms twice as wide. In fact, what it does is it makes everything twice as tall. Okay, here the red function is a height of 1 and the black function is a height of 2. Here the red function is a height of 2 and the black function is a height of 4. Okay, so everything is twice as tall. You might say, well, let's make it half as tall. That would make it twice as wide. That's not actually the case either. It's not twice as wide because when we go over here, this red mark, 2.2024, double that would be more than 4. That's not that case here. It's made it half as tall. So the trick to making it twice as wide is this. You want to put a parentheses around the x, and you want to multiply the x by something. Now, if I multiply x by 2, remember this is oppositesville. It doesn't make it twice as wide, it makes it half as wide. But if I put a half in, not a third, a half, now it's twice as wide. Hopefully that makes sense. So when you want to affect the width of a function, you need to make modifications to the independent variable x, not to the entire function. Okay? So put a parentheses around the x, put your multiplier in there. Remember, it's oppositesville. If you want to make it wider, you actually have to divide or multiply by the reciprocal of the number. Okay. Some other things that the spread worksheet talks about. It gives you a dancing robot. So it gives you this. It gives you y equals x cubed. And it gives you 3 points on the function here. -1, -1, 0, 0, 1, 1. Okay? And then it gives you another robot with these points. 2, 0.5. 3, 1, and 4, 1.5. And it wants you to find a function that fits that. Now, I'm not going to do this particular dance because that's for you to figure out. So I'm going to change it here. I'm going to do these points. I should have done this ahead of time. I'm going to do -3, comma, -3, -2. And -1, -1. And I'm going to do -1, -1. I'm going to do 1, 0. There we go. Okay, so 3 points in the straight line. And I'm going to modify the red function so that it fits the green point. Okay, so the first thing I may notice is that instead of going over 1 and up 1, we're going over 2 and up 1. So this thing is twice as wide. Okay, so immediately I'm going to do this. I'm going to say y equals x cubed, but I'm going to put parentheses around the x, and I'm going to multiply it by a half. So it's now twice as wide. Now I need to get the center moved from 0, 0. I need to move it down to -1, -1. Okay, so to do that, I'm going to move it to the left. So I'm going to put a parentheses around the x, and I'm going to move it to the left. To do that, that's oppositesville. I'm going to add 1. That moves it left. Okay, and then I'm going to bring it down, so I'm going to subtract 1. Okay, and lo and behold, I have now an exponential, a cubic function that fits the new point. So this is the exercise you're going to be doing. Okay, getting the robot to move to the proper place. Okay, and you need to describe the transformations that you're using. and write down and record the formula you use. And then the last task of the portfolio is to design your own dance. Okay, so let's do one here. Could have just done this in the first place. All right, so I'm going to let's see, can I put, oh, I can put a note. Good. All right, put both hands in the air. All right, so I'm going to make him put both hands. Y equals x squared. Okay, let's say I'm going to put your hands down, right? So to make him put his hands down, I'm going to flip it. Y equals negative x squared. Okay, put your hands down. Okay. Let's do move right 3 places. Move right 3 steps. Okay. And I'm going to make him do that by, say, y equals negative x squared. Make him move right, so I'm going to put a parentheses around the x. And right, opposites fill when modifying x, so it's going to be minus 2. There we go. Okay, and I'm going to say get twice as tall. Okay, so I'm going to do this. Y equals negative x minus 2 squared. And I'm going to put 2. So now he's twice as tall, which makes him look skinnier. All right. So that's kind of the idea. So you're going to, if you want, you can take a screenshot of your dance and in Desmos, if you like, and turn that in. If you want to do it on the worksheet provides a graph, a graph, you can use that as well. Hopefully that answers your questions.